Okay, we're here for ES modules. He had found a new traumatic machine. The way it functioned was very interesting. When the drink button was pressed, it made an instant but highly detailed examination of the subject's taste buds. However, no one knew quite why it did that, because it invariably delivered a couple of liquid that it was almost, but not quite entirely unlike tea. And thank you for Douglas Adams. ES modules are coming to Node.js. And they are invariably almost, but not quite entirely like CommonJS. So if this is CommonJS, we have a module called kettle. We require it using the regular way. And if I run it, it works. But even today, in Node 10, I think also in Node 8, you can use ES6 modules using import from, assuming you add the -- experimental modules to Node. This is still experimental. Please, please, please do not use it in production for reasons that I will show later, except for the fact that it's experimental. It's so similar. I want to talk about the similarities. I want to talk the differences. I want to talk about how to migrate to ES modules when they really arrive. A little bit about me. I go all the way back to the 80s. I'm much more than 40 years old. Testing code is my passion. I test everything I write, which has led me basically to Applitools, which is a visual testing company. We enable you to write visual tests to check how your application looks like and not just how it functions. So we were talking about AI, Simona and others. So we use AI to compare screenshots to see if there are real differences so that you won't get all those false positives and false negatives. So if you're serious about testing and visual testing, please come see me afterwards. But similarities and differences. First of all, file extension, the most contentious of them all. There is a difference. This is on the left is ESM. Yes, on the left is, CJS. So we all know the file extension for CJS. It's .js. And we have kettle.js, which is the module, and main.js, which is importing it. Perfect. Now we get to the ESM world, the ES modules world, and the extension is different. You have to use MJS. MJS is like module JavaScript. I think JSM was already used, so you can't use it. And now you have a difference in file extensions. And the rules of ES modules are very, very simple. And it's an interesting one. A module is ESM if and only if the extension is MJS. So when Node sees MJS, it knows that it has to be an ESM module. And a module is CJS, CommonJS, if and only if the extension is JavaScript.js. And I like to call them the Michael Jackson scripts because it fits very well. And there's two more rules that we have to abide by. Only ESM is allowed to use export-import. So if I want to use export-import, the keywords, I can't use them in CJS. And only CJS is allowed to use require. So if I want to require a CJS module from ESM, I can't do that. And we will talk about interoperability between the two later. It's a huge thing. Thank you, Simona, for using my slide. So you already saw this. Let's talk about named exports. First of all, named exports in CJS. How do we do named exports in CJS? We do exports.spout equals something, export.handle equals something. What we get back is an object when we require it, and we're good with named exports. How does it happen? How does it work in ESM? You just export a variable. Once you export that variable, you can import it using curly braces. Perfect. And the same looks like. So there's a very big similarity here between named exports in CJS and named exports in ESM, and we will see that there are subtleties here in named exports which are interesting. Default export. Yep, similarities and differences. Let's say, what is a default export? Let's talk about default exports in CJS. In CJS, a default export is when you don't want to export an object with lots of properties. You want to export a function. The classic case for that is factories. So this is a factory for making tea. So it's a function that gets a Boolean scalding and returns handle, spout, and T, which is scalding or hot based on the scalding parameter. And on the other hand, if I want to use it in ESM, ESM has a specific keyword for exporting default exports. So if I don't want to export a name, but just one thing from that module, this is a very common pattern, I just say export default and give a value. The value can be a function, the value can be a number, et cetera, but it's exporting a value, by the way, not a name. And how do I use it? In CJS, we all know, we just take it back. We just get the value of the require, and that's the function. And in ESM, we do the same, but without the curly braces. Without the curly braces, it's saying, please give me the default export of that module. What happens when we want both of them? Well, in CJS, we basically can't. Either we export an object with properties, or we export a value, a number, a function, a string, or whatever. We can't do both. But a lot of modules today, packages, do this kind of weird stuff using the fact that in JavaScript, a function is an object by exporting an object and then hanging properties onto it. So in this case, module.exports is a function, but I add properties to it so I can either access it as a function or I can access properties on it. This pattern is so common that the makers of ES6 decided to make it available also in ES6, in ESM. So you can do both export default and export variables, so you can get both named and default exports. And in ESM, it's really simple to use it. You just import with curly braces and without, and you get the default export and the non-default export. In CJS, it's like weird. You have to get the default export and then destruct the other properties from it. But they both make sense. And binding. Binding is the weirdest. It's like nobody cares about it, but it's in the spec, so it has to be fulfilled, and it seems that this subtlety is part of what makes the transition from CJS to ESM very difficult, and I'll talk about that a little bit. First of all, what does binding mean? Let's look at heat-up. Heat-up takes the T and turns it from hot to scalding. It's a function, and I export it. I export it in CJS, and I export it in ESM. But what happens when I import? When I import it, and I call heat-up, in the CJS case, it won't change a thing. It will still be hot T. If I console log T, it will still be hot T. Why? Because what I'm importing in CJS is not names, it's not bindings, it is just values. So once I import it, I required the value for T, that's the value I get. Even if it changes in the original module, I don't know about it because I got a value back. But in ESM, I'm not importing a value. It's not really taking an object. I am importing a name. And in ESM, that T name that I import is exactly the same variable that I exported in the module. So they're not values being copied. It's the same thing. I'm using the same variable, which is why when I call heat-up, both changes. So that's very, very subtle. And along with execution order, I want to talk a little bit about how things get loaded in ESM. First, I want to talk about execution order, then how things get loaded. So let's talk about execution order. Let's do the CJS thing. In CJS, require is just a function. It's a function that synchronously loads the module, executes the code, gets module exports, and returns module exports. That's what require does. It's very simple code. Most of it is in JavaScript, by the way. So how would this run, the main JS? I require kettle1, and kettle1 just console logs kettle1. And then I console log kettle1 loaded. And then I require kettle2. This logs kettle2 loaded. and then I write, console logs kettle2, and then I say kettle2 loaded. So the running of main.js is synchronous. Everything is synchronous because the require executes the function at the point of the require. Perfect. But in ESM, the whole thing is totally different. So if I do import console log, import console log, those imports aren't statements being executed at that time. They are declarations, directives to the loader, which says, when I get loaded, these need to get loaded. And what the loader does, the ESM loader does, is let's say it takes main.js. So it starts, it reads the file, not executes it. It doesn't execute it. It statically analyzes it, finds the imports, loads them, statically analyzes them, doesn't execute them, loads them, until it loads all the tree of imports. We haven't executed a single line. Now, once the whole tree is loaded, it starts executing bottom up. So loading is asynchronous. It can load asynchronously the whole thing. Theoretically, it can load 2 branches at the same time, so we get much better execution speed. I'm not sure it's doing it today, but theoretically it could. And then the execution starts becoming synchronous. And because it's, first of all, loading and figuring out the imports and the named imports, ooh, that is, there we go. Sorry about that. Because it's executing and understanding, it can bind the names together before the execution. That is why named bindings are so important in ESM. So synchronous loading and asynchronous loading in ESM. That's a big, huge change, and it is the main reason why we're still working on ESM in the Node.js, and we'll get to that. And if you want to learn more about that, there's a beautiful blog post by Lynn Clark, ES Modules, a cartoon deep dive. I would recommend it. It's fun. It's a cartoon-ish thing, but it goes very deep into how the whole loading thing works. Dynamic import. By the way, what's the difference between a homeless and what's the other one? A hipster? The cell phone. And that's not a difference anymore. Okay. Where was I? Dynamic import. So let's look at using dynamic import. What is dynamic import? It means importing not as part of the file, but dynamically when a function is called. So in CJS, there's no difference. Require is just a function. So I can use it wherever I want. Easy. If there's a function main, I require it there, everything's good. But remember, in ESM, import is a directive. I can't put it inside. It has to be top level. I can't put it inside a function. It has to be top level. So there's a new keyword called import, which as a function, it's not really a function, but good enough. And what it does, it returns a promise to that module. Why is it a promise and not just the module itself? Why do I need to await it? Because ESM is asynchronous. Because it's loading the whole thing asynchronously, I have to await it or .then it or whatever. So dynamic import is much different. You can't just require or import. You have to await import. And this changes the whole thing because that function turns from a synchronous function to an asynchronous function. And we'll talk about that when we're talking about migrating. And module dir name, in CJS, we have __ dir name. That doesn't make sense in a spec that works for browsers. So in ESM, we have import.meta.url. It's a URL. It needs to be munged to work with to turn it into a dir name, but it's just a simple one-liner, so we're good with that. Interoperability. Remember the rules of ESM. MJS can only import other MJSs, and CJS can only import other CJSs. So we're basically having separate worlds. We can't work together. I can't mix CJS and ESM. But there are bridges over those two. And what are they? Let's talk first about MJS importing JS. So I have an ESM module, and I want to import a CommonJS module. How do I do that? It seems that I can use import, but only default import. So I have main MJS, and I want to import kettle.js, which is a CJS model. I can do that using import. One of the words in the module Node.js group is transparent interoperability. So this works. But this doesn't work because named exports are not available, cannot be used. Why? Remember named bindings. When I do the whole going through this and loading all the modules, it's also loading the CJS. But that part, I'm not allowed to run, to execute that CJS at that part, according to spec. So if I'm not allowed to run, execute it, I don't know what the value of module.exports is at that time. And if I don't, I can only return the module.exports as an object, meaning default import. So this doesn't work, and if you want to use it, import kettle module, and then just use kettle module.kettle, and you get your named exports from CJS. What about the other way? CJS importing ESM. You're not allowed to use require. You're not allowed to use require to load ESM. Why? Require is synchronous, ESM is asynchronous. Doesn't work together. So what do? I can't use import. I can't use import in CJS because CJS doesn't allow it. So what do? I use dynamic imports. So import as a statement doesn't work, but await import as a function dynamically does work. So whenever I want to import an ESM module, I have to await import it dynamically. So those are the rules of interoperability. Default export from ESM to CJS, and dynamic import from CJS to ESM. So how do I migrate my code once we're out of experimental mode? Two ways, two things. First of all, as application developers, and not as library developers, not somebody writing an NPM package, but as somebody building an application that uses other packages. That's pretty easy. First of all, if you're using import, or whatever, stop using Babel, at least for import, etc. I would say stop using Babel because Node is like perfect for JavaScript, but hey. Rename all your JS to MJS because you want to migrate to ESM. Change all the requires to imports. That's pretty easy. I'm sure there's a code mod out there somewhere that can do it automatically. But if you're importing a CJS module, you have to change those named exports, those destructuring with the to a default import, and that's not nice, but it's possible. And if you have dynamic requires, you must change them to await import. And that's a big problem, because if you're using dynamic require, the path to that code may be a synchronous path. And you have to now change that function to be an asynchronous, and it turtles all the way up. It goes all the way up to be asynchronous up the top. So all the other changes were totally technical. You can do them using a code mod. This change may need some changes in your business logic code. What about library developers? How do I write code? How do I translate from JS to ESM? And I want to talk about dual mode libraries because we will be living in a CJS ESM world for a very long time. We won't be moving immediately, and like a year after, everybody will be using ESM. CJS is here for a long time. So I want a way to write a package that works both if I import it and if I require it. Works both from ESM and CJS. We call those dual mode libraries. So I want Kettle, and I will build Kettle to be used from import from ESM and from require from CJS. How do I do that? First of all, the rules of migration. When I require a module, a file, if I don't put an extension .js or .mjs, it will, if I require it, it uses .js, just like today, nothing changed. But if I import without an extension, it will first look for MJS. If there's an MJS, it will import it as an ESM module. Otherwise, it will import it as a CJS module with all the default imports and stuff. So there's a way out here. If I do an import, it will first read the MJS and then the JS. So Kettle can be simple. I write it twice. First as an MJS and then as a JS. In MJS, I will write the exports. In JS, I will write them as module.exports. And once I require them, I will look only for index.js, which is perfect. And if I import it, it will look for the MJS, which is also perfect. That's what you're telling me? To write the code twice? No way. There must be a different way, a better way. And the answer is no, there isn't. But, but there are ways around it. There are ways around it, and the way is this. First of all, write it as an ESM, because ESM is the future. So this is ESM, index.mjs, and this is the package JSON, where the main field is index, but not index.js, just index. So now we have an ESM module, perfect. Now we Babelize, but we do a trivial Babelization, which just transforms the imports to require and the dynamic imports to require, same. Very trivial Babelization. It takes all the MJS files and turns them into JS files. So now index.mjs and all the other files are turned into index.js and all the other files. Very, very simple, in the same folders, by the way. So don't forget to git ignore the JS files, because they're built from source and not the source code themselves. So now I have both MJS and JS, and when I import, it uses the MJS, and when I require, it uses the JS. It's a very, very simple thing, which gives us dual mode libraries for free, or for almost free. So if you want to write dual mode libraries once we're out of experimental mode, or if you want to play with it, this is currently the way to go. There we go. Okay, future. I have a lot of time. What are we working on in the Node.js modules working group? So first of all, we have lots of members. We are working on the future of Node.js modules, ES modules. Some things aren't yet in Node.js, and I'll talk about that. But we're also trying to figure out how to stop them being ---- experimental. And please, these are my opinions. They are not, from here on, they are not the opinions of the Module.js working group or my employer's opinion, who really doesn't care about this. Where are the problems? If it's all good, and I was there, oh yes, even MJS, I gave this talk a year ago, which is why I was probably invited to the working group. Thank you, Miles. It's all good. Let's remove the ---- experimental. Unfortunately, there are three main problems, as I see them. I think other members will see other problems. First of all, developers want their existing Babelified and Webpackified modules to work. They want the JS extension. They want to import transparently CommonJS modules, just like they do today with Babel and Webpack. And if you use the John Dalton's amazing library called ESM, then it just works. First of all, why can't we? Because those Babel Webify just transpile the import to require, and we're not allowed to do that because we need to really, really be asynchronous and not synchronous. So first of all, developers want that, and we need to figure out, first of all, whether we want to be able to have this ability. I believe we do, some others don't. And how to reach there given the very different nature of the two models. Second, there are no require hooks. We all use require hooks. If we use Babel Register, if we use TS Node, others, if we use APM, Application Performance Monitoring tools, or mocking, we mock modules, whole modules, we're using require hooks, which are in essence a way to plug in a very not formal way of plugging into the loader mechanism of CommonJS. We don't have that in ESM, and this is crucial for the ecosystem. We can't really have ES modules without loaders, without the ability to plug into that hook. And the third thing is web interoperability. We really want to make ES modules in Node work the same code working in Node.js and in the browser. This will be a great, great benefit to the ecosystem, and I think it's worth pursuing. So, what did I talk about? Talk about the similarities and differences of CJS. Talked about the ESM CJS portability, which is a huge issue. How to migrate your libraries. Remember the rules of migration, not very difficult. Don't do this until we get out of -- experimental mode. And I talked a little bit about the future of ES modules. So, thank you very much.